Hello, good morning, my dear students. Today we are going to do the prominent characteristics of gases. Last class we had done up to liquids, so today I will be doing gases, the prominent characters. Now let us see what are the prominent characters of gases. First of all, we have this the force of attraction between particles of gas is almost negligible. Now, see, the force of attraction between the particles of gas is almost negligible. That means there is no force of attraction between the particles of gases at all. Clear? Then, due to this reason, they have neither a fixed shape nor a definite volume. So, because of that, the gases do not have the force of attraction between the particles. Clear? So that they do not have a fixed shape as well as a fixed volume. Clear? This is the first prominent characteristics of gases. The second one, the space between molecules of gases is the greatest, which makes them highly compressible. Now see, the space between the molecules of gases is greatest. That means there is lot of space between the molecules of gases. Here, there is lot of space between the molecules of gases, which makes them highly compressible. So this is another prominent characteristic of gases. Third one is the particles of gases have greatest kinetic energy, due to which they can flow easily and occupy the entire space. Now see, the particles of gases have greatest kinetic energy. Clear? They have the greatest kinetic energy, so due to which they can flow easily in any direction. They can flow easily in any direction and occupy the entire space. So the molecules of gases have a tendency to escape. Even the molecules of gases, they can escape also. Clear? So these are the three prominent characteristics of gases. Clear? Then there are some differences between solid, liquid and gases in terms of shape and volume, arrangement of molecules, intermolecular force of attraction, intermolecular space, kinetic energy, compressibility, storage, and some of the examples. Clear? So now let us see the differences between among them. First of all, let us see about the shape and volume. Clear? In all three states of matter, solid, they have a fixed shape and fixed volume. Clear? Liquid do not have a fixed shape but have a fixed volume, whereas the gas do not have a fixed shape as well as they do not have a volume. Clear? So in terms of shape and volume, solid, they have fixed shape and fixed volume. Liquid, fixed volume, no definite shape. Clear? Whereas the gas does not have a shape as well as the volume. Second one, arrangement of molecules. Very tightly packed and have a specific arrangement. So molecules are tightly packed, clear, and have a highly specific arrangement. Clear? In liquid, loosely packed, clear, and do not have a fixed arrangement. They are loosely packed or loosely placed and do not have a fixed arrangement. Clear? And then in terms of gas, a very loosely packed, clear, or loosely placed and no arrangement exist. There is no arrangement exist at all in terms of arrangement of molecules in all three states of matter. Now see, intermolecular force of attraction. So intermolecular force of attraction in solid, it is very strong. In liquid, it is weak. And in gas, very weak, non-existent. Very weak in terms of intermolecular force of attraction. Clear? So in the gas, it is very weak, non-existent. Now another one, intermolecular space. Clear? In all three forms, in three forms of matter. In solid, intermolecular space very small. Clear? In liquid, it is larger than solids. Clear? And in gas, it is very large. Clear? Intermolecular space is very large in gas. Now another one is kinetic energy. Very low molecules move in their own restricted space. So kinetic energy is very low in solid. Remember, kinetic energy is very low in solid. Molecules move in their in their own restricted space. And in a liquid, high molecules glide against each other. So kinetic energy can glide against each other in liquid, whereas it is very high in gaseous state. Clear? Now another one is compressibility. In solid, compressibility is negligible. That means very difficult. We cannot compress at all. In liquid also, it is difficult to compress. Clear? It is difficult to compress in liquid, whereas in gaseous state, it is very easily compressible. Clear? In gaseous state, it is very compressible. Now then comes storage. Do not need a container for storage. So do not need a container for storage in solid. In liquid, need a container for storage. Clear? And in gaseous state, need a closed container for storage. Clear? Need a closed container for storage. And the examples in all three states, in solids, sugar, wood, pen, table, ball, ice, rock, pebble, etc. They are the examples. Clear? And the liquid, water, milk, juice, tea, coffee, etc. Clear? They are the examples of liquid. And in gaseous state, air, oxygen, hydrogen, helium, water vapor, etc. So these are the examples in all three states of matter. So molecules in liquids and gases together known as fluids. Molecules in liquids and gases, both of them, they are known as what? Fluids. Move very fast. They can move very fast. The speed of these molecules increases as they move. So the speed of these molecules, clear, they can increase their movement. To understand this phenomenon better, let us focus on just one particle highlighted in red in the diagram. It is shown in the diagram. Just you can see the red molecules travels straight, however it hits a molecule that comes in its path. Now just see in the figure, the red molecule travels straight, clear, however it hits a molecule, clear, that comes in its path. So as a result, it bounces faster in another direction. That means when it hits, clear, when it has a movement, so that means it bounces in another direction. So it hits a second molecule and again bunches in another direction at an increased speed. So when it come to strike in another what you call it molecule, that means it again bunches in another direction. Clear? So that means the movement is very fast. Now imagine that all the molecules move in this random manner, bunching into each other and increasing their height constantly. Clear? Increasing their speed constantly. Increasing their speed constantly. So remember, they can move randomly. Clear? And increases their speed constantly. So this movement of molecules in gases or liquid, that is known as what? Brownian motion. Clear? So this motion of molecules in fluids was first discovered by Robert Brown when he was studying the movement of pollen grains in water. So he realized that the pollen grains move faster and change their direction as they hit by water molecules. So remember, he realized, that means Robert Brown realized that the pollen grains move faster and change their direction as they are hit by water molecules. So some other examples of Brownian motions are given here. A dispersal of perfume particles throughout the room. Remember this one, dispersal of perfume particles. Clear? Throughout the room, that is also the Brownian movement. Clear? Brownian motion. And then another one is dispersal of food color in water without stirring. Dispersal of food color in water without stirring. Clear? This is also another example of Brownian motion. And then the last example is given here, dust particles in air. Clear? Dust particles in air. So these are the different examples of Brownian motion. So we will be doing this much for today. Clear? So next class we will be continuing effects of heat on matter. Okay, thank you.